Okay, hello everyone. Welcome to Always Coding. This is our weekly Hacky Hour. And today I'm Komal Devjani. I'm a developer advocate with alwaysAI. And today I'm joined by Steve Grisette and Lila Milani from our team. Steve, as you guys might know, is our CTO, and Lila is on the developer advocacy and software engineering team. So today, typically we host Hacky Hours and have demonstrations of alwaysAI features and various things you can do with alwaysAI and computer vision. But today we kind of wanted to just have a space and hold space for our community to join us and ask any questions you might have. So any lingering questions about setting up or downloading the installers or anything related to the application, we're here to support you. So this is your chance to at any point raise your hand and we'll unmute you, or if you'd like to share your screen and help us debug something, I can help you out with that as well. So just let us know what you're looking for and we're here for you. So with that said, I'm just going to do a quick introduction to alwaysAI for those of you who are new, how to get going, how to get started, sign up and download the CLI. So I'm going to go ahead and share my screen. And let's pull up. So this is the model training. So let's go on to alwaysai.co. This is going to be the first place you start, and you want to go ahead and register for an account with alwaysAI. Once you do that, you're going to be navigated into our dashboard, and here you can learn about how to train a model. And when you click train a model, you'll be navigated to this page where you can watch a quick video on how to start with model training in 5 steps, learn information about why to train your model, and then use the installers to get started. So this is what the page looks like. And you can try out our Hello World face detector. That's a good sample project to try out if you're new to computer vision. And then check out some of our popular starter apps. And most importantly, you're going to download the CLI. So what you're going to do is click install CLI here on the dashboard and select your operating system. So it could be Mac, Windows, hit next, and then click this red button here, download for Mac OS. So once you have downloaded, you want to open up and launch your alwaysAI app, follow the steps, and you should be good to go. So what I want to do is just create a new project. Let's build a simple object detection project, and let's call this office hours. All caps, office hours. And let's go ahead and create our project. So we're going to go ahead.
Are you sharing your screen there?
Yeah. Are you able to see? Are you able to see my dashboard, Steve?
I can see it.
Yeah, now I am. Sorry, I had a screen refresh issue, so I apologize.
Oh, all good, all good. I'm glad you're pointing it out. If you're not able to see it, I want to make sure we can fix that. Okay, so once you're in the project, you can also download the CLI from here. We also have that button here, and then check out the model. So here, let's try and add a new model. Let's go ahead and navigate into our public model catalog, and like I said, we're going to run an object detection model. So let's just scroll through and see which model would fit best. For my case, I have lots of plants at home, so I want to find something that can detect plants. So scrolling, and let's see, this one works, the SSD mobile net Cocoa model. And let's see, does this have a potted plant here? I believe it does. I just have to find it in this list.
I see it.
Perfect. Okay. So yeah, it does have a potted plant on here. It can also identify a vase, potted plant. I have a dog who's upstairs, but if he was downstairs, it would identify that as well. And let's just go ahead and click this, and we're going to add it to our office hours project. Okay. And then let's go back into our dashboard, into this project, and refresh, and it should be added on here. So it looks like we're good to go. Let's just go ahead and delete the MobileNet SSD model because that's not what we're using. So now you just want to follow these commands here. So copy the first command here, which will configure the project, and paste it into an empty directory. So I've already set up my directory here. And I want to proceed with the download. So yes. And as you can see, it found that model that I just added from the model catalog into the project. And I want to save it locally. And then from here, if you can see, just follow the steps written out here. So that will be AI app install, and then AI app start. So it's actually identifying the MobileNet SSD model, and I know why. It's because I need to go in my app.py files And this is great. So this is a good way for us to see. Let me just kill this for a second. And let's go ahead and open that app.py file. alwaysAI directory. So this is my app.py file. And then as you can see, the model that's added on here is the MobileNet SSD model. So let's go back to our model catalog, and we want to specify that I want to use this Cocoa model, not the MobileNet SSD model. So what we want to do is just paste that on here, hit save, and that should be good. So let's just make sure this is done. And then let's just go back from the top and go ahead and configure the project again. So copy this. Oh no, that's not what I want to do. So we want to copy this command to configure the project. So let's try one more time. I want to save this on my local computer and then do an AI app install. And then AI app start. And here's to hoping that the Cocoa model's working. And yes, it looks like this is the model that's working. Beautiful. So we're going to copy this streamer link and paste it onto an empty web browser. Hit go. And let's see, it can identify me, which is a person. It can identify my couch, which is good. My TV over here. And then can find the plants. That was the initial goal. And yes, it can. And that's how you run the simple object detection.
Nice. Actually, can we stop for a question real quick, Como?
Yeah, totally.
So Zaibi, I hope I'm pronouncing that right, is asking if we train our custom model with alwaysAI, in which model type will it return as the output, and what types of models can we train with the alwaysAI CLI? So I thought that was a good, because you were pasting that model name into the app.py file. This is a good spot to answer that question.
Wow.
So I'll take a first stab, and then Komal or Steve, if you want to jump in. You can train object detection models. We use a retraining on the MobileNet that Komal originally put into, or that comes baked into that starter app. So they're only object detection models. And you have two frameworks you can choose from. The faster RCNN is a heavier, it'll be slower, but possibly more accurate, probably more accurate. And the MobileNet is a lighter weight model. So when you train it, you either give it a name yourself, which then will be your model ID will be something you provided, and your alwaysAI username will be that preface, that alwaysAI/MobileNet will instead be like username/model name. And if you don't provide a model name, then it will just make one up for you, and you'll have to make sure you take note of that. And then you can copy paste that into your app.py files, and you can find it on your private model catalog if you publish it. So it's the same process, it's the same format. It will just be your private username and your decided model name. And then you can swap that into the files, add it, remove it, just like you would any other alwaysAI model. So anything with alwaysAI is something that's in that public model catalog. Anything else is a private model or a model that another alwaysAI user has shared with you on projects. I don't know, do you guys want to add anything, or if
I mean, you're spot on that. The only thing I would say was a second model that Kamal added. So we support mobile SSD through in the TensorFlow architecture. The first one she had was the cafe version of it, and so forth. So that's the only correction I'd have, and I would not recommend running RCNNs on an edge device.
Right.
That's the other piece I would add. So, unless you want 3 to 4 second response time.
That's a very good point. But that's a good question. Yeah, because that's
great question.
That's a big point of why, like how we're trying to make this process better, make prototyping easier, make application development easier, is that you can train your own model. And we have lots of Hacky hours in the past that go over this in a lot more detail. You can collect your data set, annotate it, train it, and then just swap it into an app to test it out. And it will work like another alwaysAI model, because it's just a standardized process.
Yeah, and just on futures on that, then the next version we're going to get is so MobileNet SSD is very fast, so it's really great for edge devices and so forth. The next one we're going to come out, it has higher accuracy, is the YOLO, and so
that was the next question that somebody just typed
so we're
in.
looking at supporting YOLO 3 and 4. And you know, in tinies too, if you want to go with a little speed on YOLO, and so forth. So that will be the next version out. We're looking probably at the end of this quarter for that type of release. And what I will say is, we have within the process, we have you just reach out to us. You can develop it all the way down to a TensorRT model if you want to, or we've all seen iCloud. Any of those two choices we have, we can also support the OpenVINO pieces. So if you just contact us, we'll help you compile down your engine. So right now, if you have a MobileNet SSD and you want to move it over to TensorFlow and you built it through our kit, just contact us in Discord and send us the model and everything, and we'll compile it down for you and put it into a TensorRT format if you're running on the NVIDIA platform. So there you go.
Can you, Steve, just elaborate a little bit on why someone wants to convert it from a MobileNet to a TensorRT or an iCloud, just for people who don't understand why that's needed?
Yeah, so alwaysAI inferences mainly on the CPU and then OpenCL GPUs, right? So you get pretty good performance, right? Especially on a mobile SSD. But if you really need closer to real-time type of accuracy, you're going to want to go to a model accelerator. And on those, if you have like iCloud is our camera bundle and everything else like that, you have something you need to have a fully operational camera, and you want it to accelerate and everything else like that. That's why you want to do it. And that will get you probably, let's just take YOLO, which, because I'm working on that project, I have the thing. So on YOLO, well, let me actually, let's get out, since I am performance testing, right? So let me actually, I'll get the screen here in a second. Let me open it up and we'll do a little performance testing. Let me go ahead and share my screen here. Sorry, multitasking is not a great thing for me. But if we come in, and I'm going to share my main screen, so hopefully you can see my screen.
I can see that.
And let me go ahead and find what I did with the thing. So we've been doing some performance testing. And basically, we have the model type performance and are using a CPU. Are you going at like a NVIDIA system with CUDA, or are you running their TensorRT? And so these are the SSDs that we just talked about that Kamal demonstrated to you. And so if you look at them on a CPU, and this is all run on an Xavier. So an Xavier is a higher range NVIDIA edge device, Jetson device. So that's, we're looking at this for one of our customers and so forth. But anyway, what you're going to see is about 120 milliseconds on the CPU, right? Tapping the GPU that's on the ARM device. So ARM molds often have a GPU device on them, a very simple one for video. The next one is really the CUDA-based interface. And then you can see if you go into CUDA, and you can hit that just by using our parameter on CUDA, you're going to have a 15 millisecond response time. So now you can see I can start doing some really great real-time type of stuff when I get to that. I mean, I can run around the camera, or I can have like an Olympic sprinter run around the camera and still track them, right? So not just slow Steve, but a real actual runner. You get down to TensorRT, and then you're even going to get a bigger performance gain, and that's going to be around 9 milliseconds. And you can see I'm including our overhead of processing and so forth, the thing. So then you get down to your FPS, which a lot of times, a lot of people see the benchmarks on NVIDIA, and I just want to tell you what NVIDIA does. They're a partner, and they'll probably throw rocks at me if they're on this thing. But what they do is they take an empty clip and they run it through. So what you see on their FPS is the inference time per second, not a frame per second. So this is frame actually processing, drawing everything out, getting a results objects, putting your bounding boxes and everything else like that, which is performed on the CPU, right? So what we see is on a CPU on SSD, we do about 8 frames per second. Then we get down to CUDA and TensorRT, and you're really around 20 frames per second. And that's a fully processed video. And that gets important for people that have to see output and so forth, you know, right down to I'm seeing it on my screen. So it's visually rendering on the screen on it. We go down to YOLO. So YOLO is very precise, not quite as good as RCNN, but one of the more precise models you can run on an edge. If you come in on a CPU, you're almost at 2 seconds on an inferencing time, and you're dropping down to 0.46 on frames per second. And again, that's going to be very difficult for real-time stuff, but there are many things you can do that doesn't involve real time. For example, we had a customer that was monitoring parks that wanted to count to see usage on a park and so forth. And they were able to really do that, you know, by sampling, right? So they didn't need all the FPS that we're talking about and so forth. So there are applications where you simply sample and you want to sample accurately. So it's fine. You can run on an ARM CPU, right? But if you get down and you run on a Jetson product, you can start to get that down to 133 milliseconds, and it's running at 3 frames per second. You get over into TensorRT, and now you can start to see YOLO v3 running at 32 frames per second. So you have 32 milliseconds, sorry, and then 20 frames per second as the overall rendering. And so you can see now all of a sudden you have high accuracy on these platforms and these Jetson platforms, and why professional people use these platforms. You have high precision and you have high frames per second. So it means that you have a lot of areas you can apply the system to and so forth. So, and then again, this YOLO v3 was done at what we call 32-bit precision in the model. So and then down here I have, this is what happens with floating point. And I went over and we were just testing out CUDA. Right now I haven't done a TensorRT model on that yet. But anyway, it's running on a floating point 16 precision. So you lose some precision in the model, which means it's not going to be as accurate, but you get some speed bounce on it. 53 milliseconds. And then you're going to see 3.5 FPS and so forth. So sorry, this is long blown out, but it starts to show you these are some of the inferencing times you can expect. And again, these were all done on the Xavier and benching. Now, on alwaysAI, we basically regress every model that we have in our model catalog, and TensorRTs are actually inferencing engines, and I'm not going to get into the distinction here. You treat them like models. And anyway, in there, you'll find out for the different types of devices that we have inferencing times on the system. So if you want to see those on everything, you can see that. But this was just a little comparison that we were doing on the Xavier. We have a customer that's working with Xavier, and so we wanted to know some stuff. So there we go.
Sweet.
Sorry
That's
to
great.
dominate, but
No, that's probably really helpful, Steve. And so actually, we do have a question relating to that. So it says, if we attach the Google Coral accelerator to the Raspberry Pi 4, does alwaysAI support that for training and inferencing, or?
No. So we steered away from the Coral board. We decided, and in general, let me tell you the direction we're going to be going. So the industry is marching slowly but surely towards PyTorch. And although we supported TensorRT and TensorFlow, excuse me, and Caffe early on, we are moving towards that same type of PyTorch architecture and systems. So long thing short, we aren't going to go TensorFlow Lite, which is what the Coral board supports, and we want to stay more mainstream. And we see the more mainstream being the Intel accelerators on the Myriad, which is going into all kinds of embedded devices and so forth, and NVIDIA's Jetson. We looked at Google as being just kind of their TPUs being a one-off architecture that we don't think has long-term sustainability in the marketplace. And we also think that PyTorch will ultimately be more of the dominant. And we've seen the transitions. We started out as a company that supported Caffe. We moved to TensorFlow, and now we're moving to PyTorch. So there you go. So yeah, today, long-winded story, we don't support TPUs.
I hope that was
support NVIDIA GPUs though, both in training and execution.
So, but to that point, Steve, how might one increase the accuracy of a model without compromising frames per second?
Well, again, like I said, one way is, and I'm not the best model person. I may kick it over to Lila and one of the other people. I stand more time. Well, I guess I spend time on the inferencing, but what I said is really for me, it's again, it's going to be model architecture. So YOLO is always going to be more advanced than MobileNet. So choose your architecture, and there's lots of papers, and you can see in the academic papers, this one has higher precision, this one has less precision, and there's always a trade-off to speed to precision, right? The next thing is when you're looking at it, particularly, like I said, you have floating point 16, 32, int 8, and int 8 is very fast, but you're going to compromise accuracy. Right? Floating point 16 sits in the middle, still get most of the accuracy you would see published in the white papers on a model, but floating point 32 is going to give you the highest precision. And as you saw, we get down to, so average webcam is going to go at 30 frames per second. If you look on the TensorRT models that we're sitting at 32 inferencing time, we're getting close to 20 frames per second on MobileNet. So at a FP32, you're keeping the integrity, and you're also getting the speed of the model. So, and I guess in general, the more that you are going to optimize your model and do different things to it, you're going to lose some of that precision for timing. So I don't know if that answers the question. It's long drawn out. It's an art, not a science, I guess, in some ways.
I would second that. I do see Todd in the people chat. I don't know if he wants me calling him out. I can definitely speak to some stuff you can do.
Yeah, Todd, you're the experts, Lila.
But Todd's the expert. I think he wrote the blogs on data collection, and he's done some good tips. So if he wants to raise his hand and jump in, he should feel free. But otherwise, oh, there he goes. Yeah. Otherwise, I could have done some.
Hello, Todd.
Hello. Yeah, I've never raised my hand before. Hello.
I know.
So, by the way, optimization is called quantization in the model type of thing. So, the less you quantize, the more accurate you're going to be, and there is a balance.
Right. I think. Yeah, I was just saying. I think for the speed, that's kind of defined, at least in our experience, we find that's defined by the architecture and by the model. So when we train a model with our tools using MobileNet and using faster RCNN, we get pretty kind of static inference time with the results of that model. Like all the models we produce are pretty comparable when it comes to inference time. So you're not going to get any better or worse. So then improving the accuracy just comes down to your data set, to the variability, your annotation, how well have you captured the scenario that you're going to deploy in your data set, how well it relates to it, and kind of how varied that is. So that's kind of what we try and do, is kind of the first place is expanding your data set and filling in gaps. If you when looking at your model, see things that you think that it should capture, but it's not, try and get examples of that in the data set is how I would address it.
Yeah, I think that is the biggest problem. I think sometimes you don't realize what your use case is, or maybe you haven't defined it as well as you think you have, and so your data set isn't reflective of how you really want to be using it. But I also think that, at least, for me, coming into alwaysAI, pretty new to computer vision, especially model training, it is a pretty simple process. It's about as simple as you can get, because like Scott likes to say, we're not like performing magic here. There's still some basic fundamentals that you have to do, but you can go back, retrain, collect more images, reannotate, retrain, test it out. I think it's about as painless as it can get without losing, you know, there's that trade-off. The easier things get, the less customizable they are, the less, you know, control you have over certain details. But I think that if you test out your model, you see it's not performing well, then you just go back, you collect a little bit more, you annotate a little bit more, keep training a little bit more, and test it again.
And to that point, what would you say are some best practices for data collection for model training? So how might one consider data collection in terms of like lighting or the production environment where it's going to be used?
Todd's got some, Todd like wrote the book on that. If you want to answer.
I wrote the book on, did you, Todd?
Or at least wrote the docs on it. Yeah.
Right, we keep
Hopefully
expanding
the royalties
our
are good.
blogs.
Yeah, it's going to turn into a book. Yeah.
Right. Yeah, I think, I mean, the most important thing is just capture as you're going to be inferencing. So kind of understanding where you're going to be deploying it, and then try and get examples of that. You know, if it's daytime, nighttime, and then I think also just iteration. So a lot of different times I'll run a model and then deploy it and just watch it and see, you know, for example, the hand model. The data set I used was a lot of like top of hands, but when I hold my hand up to the webcam or to the camera I'm using, like to see the underside of the hand, it couldn't pick it up. It was having trouble with that. So then I focused on gathering data to fill in those gaps. And recently I've done it with augmentation. So not actually collecting more data, but just using image aug, where I noticed for, you know, a mass detector, where if I turn my head 90 degrees sideways, it stops recognizing it as a face, just because there wasn't enough examples of that. So it's kind of, and then so I just was able to augment the data set just by rotating it with an external augmentation tool, which we're looking into implementing. But I think it's watching the model perform and iterating on the data set on kind of gaps that you can see as you're testing.
Yeah, and I think what Todd says, it is testing and things like that. So just as what you saw Komal do on our system, you can do that while your model retraining before you send it up. You can go ahead and deploy to your edge device, and you can see what's going on, what your performance and your speeds are going on. So we have this really nice workflow, because again, we're edge device oriented, or you can run it on your PC if you want to. That's definitely an edge device. But if you want to go down into the you know, more IoT type of space, you can do that, and you can keep iterating over and over, and you can see what that performance is going to look like on that device and so forth. So sorry, Todd, to jump in there. I just wanted to make sure you were adding.
That's perfect, because it's so easy to publish the model to your, you know, personal models, bring it down and watch it go. And then continue training, you know, from the point you left off. It's really easy to iterate.
So again, in this is kind of a new format. We decided that we want to make sure our last time we ran this, you know, we had a lot of questions on how to use software and things like that. And we were there going, hey, here's, you know, what we're working on, but we wanted to get the community more involved. So guys, we will open up the mics coming in. We can let you talk and ask your questions. We will let you share your screens if they can. I don't know if they can, Komal, but oh yeah, they can. Komal's in charge, so I should know that. but all this type of stuff. So you know, just raise your hand. You can bring your problems, and we'll try to answer them. Or you stump us, and we'll get back to you on Discord as we try to work through it. So one of the things we just wanted to do this, and I just think it's a good time for people just to share what they're doing and working on and questions. And again, if you have the answer and we don't, we'll let the community also answer. So this is kind of your time, and we're trying not to you know, dictate to you what we're seeing. So we decided at least every other week we're going to be doing these office hour type of thing.
Yeah, and more if necessary. You know, if we see that there's a lot of questions, we're happy to just stop whatever we're presenting and take questions, because we want to hold space for you to ask your questions. Yeah. So to that point, we actually have a question. So Can you elaborate a bit about dealing with head turning face recognition loss?
Yeah, so I used a data set that one of our community members collected, kind of found images on the internet. So for mask list, it was a dual data set of people with wearing masks and then faces not wearing masks. And as you could assume, most people are upright all the time. So a lot of the images found were, people walking down the street, or a lot of the non-masks were celebrities and athletes. But a lot of times the pictures, that how you normally take a picture with just kind of your head centered in the frame, and at a not that big of a difference in range and not that big of a difference in head angle. So when I trained the model and tested it on my system, kind of just my webcam of my laptop, I noticed just kind of tilting your head, like a confused puppy or something like that, kind of tilting it, like I was thinking that it would lose the box for no mask and it would lose the box for mask, kind of not recognizing a sideways face. And so I reached out to Lila, because I know she's used the image augmentation tool before that we kind of have. It's a open source, I think it's called like image augmenter. Is that what it's called, Lila?
It's like a Python library, IMGAUG, imgaug. I don't know how
I'm gonna put that in the chat though, so people know.
Right, yeah.
But it was something I wanted to test out, to not, because like I said, for the hand model, I took a couple of videos of my hands and then annotated them manually, and that was not something, it's not that big of a deal. But if I could avoid doing that by using the image aug, I wanted to try that. And so we were able to implement that and take the data set of about, I think it was 2,000 images, and run, I think, 9 different augmentations on it. So I did a couple dual, like rotating 90 and brightening it, rotating 270 and darkening it. So kind of doing dual augmentations there, get 2 of one, doing grayscale. And then, like I said, since the heads were kind of centered like a picture, I also scaled it down so that hopefully we get examples of smaller heads and farther away. So ran that and turned the 2,000 images into about 18,000 images. And when you do that, you don't need to redo the annotation. So it scales the annotation box with the images, and was able to retrain. So this needed a lot less epochs after that, because it went from 2,000 images to 18,000, which with only slight differences. So kind of one epoch is almost 9 epochs. So after 20 epochs of retraining that, it was able to kind of get the head tilt, because now it had a good number of examples to learn from with sideways faces, both with masks and without.
Yeah, and I will say that the pairing of the annotations and scaling those down, the library helps you get the bounding boxes and whatnot. But we wrote our own code to do that as a set, so the benefit of making the annotations first and then augmenting the set, that was kind of something that you have to implement on your own, although the library does help out quite a bit. But it's definitely better than just augmenting straight images and then having to annotate, 18,000 new images. I don't think we would have had time for that.
Yeah. We actually have a couple of questions from YouTube. So by the way, this is being streamed on YouTube. So if you ever missed the Zoom link, you can always check us out on YouTube. alwaysAI is the channel. So the question is, do we have Keras on our roadmaps? This is a Steve question. At some point, do you plan on supporting Keras in alwaysAI?
I don't. I mean, it depends what you mean by Keras. So if we're not going to. Keras is a model retraining tool and so forth, and we will look at supporting people that create model in Kerases. But if you're using Keras that's your modeling tool as opposed to alwaysAI's tool. So go ahead and use that. We certainly can do the inferencing and runtime and deployment of applications on that. Right now, what you need to contact us on, so let's talk about this a little bit. So if you're doing Keras and you want to use alwaysAI, we support TensorFlow 115 and what we've tested. So 113 through 115 we've tested. Todd can argue with me bluntly, but that's what I remember, Todd, unless you guys have done something more than that. The other thing that runs into problems, and it's much like OpenCV, is we don't support H5 file system yet, so you have to convert. We'd be glad to work with you on the conversions. Just come to Discord and we'll talk you through it and work through it. So we have customers that use Keras and they create their models. And the reason is they're looking for more diverse architectures than what we have. And we think Keras is a fine tool. And they go ahead and they use that tooling system and build the models. And then the thing just becomes a conversion rate. We don't support TensorFlow 2.0 yet, or 2.x, I should say. But that's the TensorFlow that we support. Todd, anything you want to add to that on it?
No, that's summed it up pretty nicely. So yeah, we're using TensorFlow. Ours is built on TensorFlow 1.14 instead of Keras, and right now we're not planning on implementing Keras in our training tool.
Yeah. But it's a fine tool, so I don't want to do that. You can use our annotation with Keras if you want to. You can use our data manipulations, data set manipulators with Keras and so forth. Keras just takes over the model training and so forth that we have in our function. So we are rivals there, but again, we love Keras and we love the Google stuff except for their TPUs apparently. So
right.
Go ahead.
I guess I was just going to say, if you're looking for some of the kind of advanced configurations or kind of the more control of the model training by doing it manually through Keras, where ours we kind of set the hyperparameters, kind of optimize those, and try and make it a little bit more push button, just upload your data set and go. That's kind of what we're working towards. On the roadmap is kind of exposing some of those more advanced configurations to give you that control and add additional models and from MobileNet and the ResNet.
Okay, Todd, we're gonna keep you online here. So people have said, okay, you use this word epoch. What do you mean by it?
Sure. So Epoch is running through is kind of one round of running through every image in your data set. So it's kind of a way of standardizing the length that you're going through in model training. Because if you're saying, I ran through 2,000 steps, that doesn't give enough information. It's a lot different if you have 100 images in your data set and you run through 2,000 steps, or if you have 10,000 images in your data set and you run through 2,000 steps. One of those is running through each image 20 times. The other one is not even running through every image. So that's why the kind of standard is used the word epoch, and that is defined as running through every image in your training data set one time. And that kind of is a way to communicate how much training you've done on a particular data set for a particular model.
Great. And then I think you referred to a framework earlier, Steve. So the question is this framework scalable? Can it inference big images or videos using multiple machines?
So when I use, I forgot how I use the word framework. Is it in? Framework's an interesting word. So what I meant by framework is I was talking about the different, what I would call large movements in models. And so TensorFlow is what we call a framework, and within that. So and within that, yes, it can handle anything large, small. Most of these things called frameworks can do that. Cafe was another type of model training framework that was put out there. There's another one called DarkNet, which my favorite, just like the name. But that's what YOLO is made off of, and that's a framework. So that's what we mean by when we use the term framework. PyTorch is a framework. So these frameworks allow you to create models and usually have multiple architectures that are associated with them. You know, we support more like if you're in semantic segmentation, there's an efficient net framework, right? Where you can build semantic segmentation models and so forth. So there's these different frameworks that are out there in model retraining. Now, the good thing about what we try to do with ours on the runtime side is normalize the models as they come in so that you can use them across our inference engines or other people's inference engines. So like we support completely the NVIDIA inference systems that have been coming out and Intel's. So that you can run, or ARM CPU devices, you can run different models, different frameworks within our system. So you could have a mobile SSD, which you showed today, that was built, first one, on a Caffe framework, right? And it's still mobile.NET SSD. So the architecture of the model is mobile.NET SSD, but used a Caffe framework, and we run that model, right? Then you switched over to a TensorFlow framework, and you ran another mobile SSD developed in that framework. So hopefully, you know, that's what I meant by it. So hopefully that adds a little bit of understanding. So you'll see different framework movements. So right now, like I said, the movement in the industry is towards PyTorch and that framework to develop models in and so forth.
Yeah, would you say PyTorch is scalable and like allow for inferencing larger images and videos for
Yes.
multiple machines?
Yes, and again, you're gonna, when you say use that word, you know, you have to decide, you know, where you're going to, you know, when you say multiple machines, you know, is it multiple IoT machines, you know, or if you're dealing with really, really big stuff, like when we talk about RCNN, where we're going to apply RCNN is automatically annotating. So self-annotation is where our plans are putting to RCNN, and we're going to run that in the cloud. All right, that's the annotation. If you're going to do large video, multiple GPUs, those are cloud-based systems that you're going to want to run on and so forth. If you're looking at, you know, edge devices and so forth, like again, you're going to choose an architecture and so forth. But the frameworks will run across those different types of systems. So TensorFlow can work up in the cloud for, you know, for large processing bases and so forth, where you don't need quote unquote real time type systems, or TensorFlow can be put into can work on an architecture that can run on a edge device. You know, so if you use mobile SSD, there's an architecture that can be run on lots of edge devices and so forth. So hopefully that answers the question. Good question.
Yeah, I hope so too. Zabi, if at any point you want to like clarify your question, you can raise your hand and I can unmute you so you can just chat. Like,
yeah.
And Steve, I know you answered this already, but this is another one from YouTube.
Probably not well. Ask again, so I'll try again.
I think you addressed it, but just to clarify, Jetson Nano supports TensorRT, right?
Yes. So across the board, so from the big GPUs that run on your desktop, so that is the inferencing engine support. So in NVIDIA systems. So for NVIDIA, the ultimate performance comes out of TensorRT, and it's actually an inference engine, and it's compiled down. So you take a model architecture, you can compile it down and so forth. So that is supported across the frame. So the Nano, the TX2, the Xavier's, both XM and AG, all support that, as well as your desktop GPUs like Tesla and other things that are out there on it. They all support TensorRT. Now, we have two ways of interfacing in. From our engine, we can go to CUDA, which is one of their software. And what CUDA does is it balances, it has the ability to load the GPU, and it also has the ability to work on the CPU and balance the workload. So, and use a multi-processing system going on between the GPUs, which usually they're banks of GPUs, and the CPUs. So this was software developed by NVIDIA. We also support the, that CUDA library system, so that if you look at like object detection or even semantic segmentation, if you put in CUDA as one of the parameters, and again, we can go in more in depth if people want to do that, you can, and again, somebody put up the Hacky hour for that. We went through a Hacky hour on that. You can get a lot of the performance benefits. So if you saw in that chart I put up earlier on the Jetsons, just using the CUDA interface is going to jump you pretty well, and you don't have to create the TensorRT models. And we handle all that manipulation and so forth in the back end just by that CUDA. If you go to TensorRT, you have to have a compiled inference engine that comes out and load it. And it will load similar to a model. So hopefully that's not too much information, but that's it. But it is all NVIDIA devices, GPUs.
Just enough information.
One last thing that we see common: no, AMD and no Apple GPUs do not support CUDA or TensorRT. It is a NVIDIA system. And if you're serious about computer vision and machine learning, by a far stretch, NVIDIA is way ahead on this type of stuff. So, so both for training and running, and they're not even close, Google's the closest with its DPU.
Yep, and their stock price reflects that.
Yes, it does. For lots of reasons. Google's a good company.
And then the next one, also from YouTube, is does EdgeIQ support object re-identification, or is that dependent primarily on the implementation? So for object tracking, for example.
Yeah. So the answer is yes, but I'll let the expert, Lila, come in and talk a little bit about that. So the answer is yes. We have a couple tracking algorithms, and then we're even getting ready to put out some improved algorithms over time. And she'll probably put up, well, I don't know. Did you do a Hacky hour on it? I think you did a Hacky hour on tracking. I don't know. But anyway, we'll let Lila go on tracking. So the answer is absolutely, totally yes. And tracking is very important. And so with that, we'll go over to the tracking person.
I would say, I don't think Steve Bottas is on. He's definitely the pro. I've just been kind of looking at what he's been doing. So he's been doing some stuff with reID. That is more of an implementation, though. That's not something that is just like, you run it through a model, in the sense that he's building stuff. He's working with that. He knows different implementations, that sort of thing. That's like a developer thing. I think it would be very hard to make that like push button, because it would,
right.
But it's like feature extraction, and you have so there's that one component, then there's a component of like, who are you re-IDing? That's the whole thing. But tracking is definitely something that's in EdgeIQ. You can use the API to you pass in object detection predictions, and what you get out is this prediction looks like it's this object that I saw in the last frame. So object 1 or object 10, so that could be person, or it could be plant, So I don't think we've done a Hacky hour that's centered around tracking. I know that we've mentioned tracking before.
Yeah,
like as I'm saying this, I remember saying the person with the prediction. So right now we have two trackers in EdgeIQ. One is ceneroid tracking, which is really tracking. It's putting a tracking in the sense that you probably mean tracking is what I mean, is an object ID with a prediction. So you can say, this is person 1, this is person 2. The other one that's in there right now is a correlation tracker. And what that primarily does is it reduces the strain on your system. It doesn't run object detection every time to get those tracking bounding boxes. What it does is says, for 10 frames, I'm going to run this correlation tracker, and that will reduce the load on my system. But what we've done, and what we'll release in a bit, hopefully, is a more standard interface, so that when you use that tracking, you also get the object ID bounding box dictionary that you get with the ceneroid tracking, so that you can say, this is person 1, and you also have that reduced load on your system. Did you want to add anything, Steve?
Yeah, no, just the correlation. So we have two trackers right now, ceneroid, which is based on Euclidean distancing, basically on it, saying that, if an object is closer, it's most likely that object from its last frame. Right. So that's cool. That's ceneroid tracking. And again, that has the reIDing up and stuff. We built that in. Correlation tracking is saying I'm correlating a set of pixels, right? And it'll come back saying these are correlated, these are correlated, these are correlated, right? And it gives you a response on that piece. And so that's the correlation tracker. It's raw right now, and as Lila says, we're going to put the same type of basis on reIDing and so forth. But the reason you want to use trackers and why they're important to use object detection. So there's load on systems and so forth, and it really only applies to CPUs, by the way, the load. Yeah. The correlation tracker will also pump up a CPU, but not as much as object detection running on a CPU. But the problem is smoothing detection. It gets really important in your application. So what happens with an object detector is it sorts and orders by confidence level. So I have 99% confidence this. So that's at my top of my thing, and it usually gets my bounding box 1, 2, 3, 4, right? But those confidence can jump on moving objects. And so it makes it, especially if I'm doing something like a navigation system or something like that, it causes things to bounce. And you really don't want the bounce. And what tracking does and re-identification does, and I'm just saying the robotics type of thing, really gets rid of that bounce and correlates it, especially, with ceneroid, with reID. We're also going to, hopefully this year, and I don't know when we're going to do it, but we're definitely testing it with customers, as Kalman filters will also come in, which is another type of tracking. Yeah. And that will
smooth things out more too.
Yeah, and that will smooth things more out and so forth. So all those are, I think, really important, especially when you're trying to track people or objects and so forth. Like I said, if I had an autonomous vehicle, it's really important to jump between the two systems so that that navigation system understands what's going on. So you're not just jumping it around on objects all over the place. So you can also use regions of interest to help smooth things out too.
That's a good point. Yeah, and
what I mean by that is I'm in zone 1, which is my head zone. If I'm autonomous robots,
I'm look at stuff in zone 3,
things like that. So you want to use a thing. So now I probably totally confused people, and I apologize. But tracking is important. We do support tracking. We do support re-identification on ceneroid tracking. We're going to do it on object detection and column filters.
Right. Yeah. reID in terms of like the boxes, like is this box the same box, not is this like specific cat the same cat or something like that, only in terms of the box. I mean, that seems obvious, but I just didn't want to think of people. Is Steve Steve with all this other like personal data? It's not that. Is this thing that was in the same location the same thing that was in
how's it
slightly different location than the last frame in the frame before? Yeah. And we're working with some new algorithms, like Steve said, that implement Kalman filters to smooth that out a little bit more. And I also would add that when I've tinkered with stuff, and if I use like MobileNet versus YOLO, the tracking is much improved when I switch to YOLO, because MobileNet boxes themselves are less predictable. And like Steve said, it's that confidence, and consistency with the boxes themselves. So, you'll get reID, but I feel like the objects will be dropped a lot more frequently. And you can also tinker with that stuff too. I've noticed that when I have different use cases, setting certain parameters that come with those trackers, like how many frames, like if you have really fast moving objects, you don't want to say time it out after 20 frames or something, because 20 frames, the object will be gone. You want to have it a shorter window. You want to have so you can tinker with some of that stuff depending on your application. That's probably getting a little too in the weeds. We do support tracking and re-identification of bounding boxes. It's the ceneroid tracking and correlation tracking. And we're going to come out with more stuff if that is like a succinct answer to the question.
Yeah.
Okay, and the next one is, can we do finger pose tracking with alwaysAI? It's like grasping, holding a bottle.
Not yet, but we are working on that particular set of stuff. So right now, We are working on reworking our pose estimation to make it better. And then hopefully, Todd, on the roadmap, after we finish object detection, we'll put pose estimation into the retraining. But we're working on that piece, and then Tyga, one of our engineers, is going to start to implement the pose estimation pieces on that particular thing. So you'll see hand pose estimation coming in soon. I'm hoping in this quarter.
Sweet. Okay.
When we were out doing, when pre-COVID, when we were out doing hackathons at the different colleges, that was our number one thing people wanted to see and do, and so forth. And there's all kinds of, we'll get that done and so forth. And like I said, vote off and to Todd, send Todd some stuff on Discord. Let's get pose estimation as the next retraining thing in alwaysAI after object. So that's my vote.
Yeah, if people want to see features, they can always go on Discord and enter into the feature request channel, stuff you'd like to see, stuff that you think would be useful. And to that end, I would say Hacky Hour content too. If you have stuff that you really want to see a Hacky Hour on, or if you want to put office hour questions there ahead of time, maybe if you want to see something run on a device or a certain model that might take us time to prep that we can't just, whip out. Like Steve had some great stuff sitting on his desktop because he's working on cool things, but maybe we need a little bit more time. So you can put that stuff on Discord. And before we leave today, I'll make sure that I put the Discord link in the chat just so people have it.
Yeah, just to come in, I want to do one more screen sharing here. And if you go into our APIs, right, this is in our docs. And we're talking about, if you want to know about object tracking, just go in. There's the correlation tracker with some code stubs and the different parameters in it. There we go. That's correlation, and then the ceneroid tracker and how to use it and so forth on it. So I want to tell you, it's all in there. You don't have to worry about the details. Here's what she's talking about: deregistering, max distance, as we're using the Euclidean, some of the stuff in there on it. There you go. So it's all in there on that, and then you can build up on the more logical layers that we're talking. You could probably even correlation, add in the re-identification, and build out that logic yourself. But all the base is there for you. So anyway, we have pretty good docs.
Yeah, check out the docs, and I also posted a link to all of our older Hacky Hours. So take a look at that, and then you can follow along all of the tutorials we've done and check out all the features with alwaysAI. And like Lila said, if you have any specific requests for a demo, just let us know. And then there is a question here saying, I think we answered this earlier, but is it possible to retrain a YOLO model?
Not yet, but it's coming. It's coming. That's our number one, one of many of our number one priorities. So we're hoping, I don't know, Todd, within this quarter, do you think? Probably March?
Yeah.
So,
yeah, YOLO is right there.
Yeah. So we are going to get YOLO in there, and it'll be both V3 and V4. So we'll get that done. So.
Yeah, and someone's asking about whether we're doing trivia. We will do a trivia later on, maybe end of the quarter. So stick around and focus, and we might ask some of these questions back to you, and you can win some prizes at a trivia. All right, so I know we're at the top of the hour, so if you guys have any more questions, definitely use the Zoom link.
I think the side elevations are the
I'm sorry, the Discord link.
That was just, so Todd and his wife share an office, for those that work with Todd. And his kids sometimes share his office too. So that's all you heard was Todd's wife coming in. So.
I thought maybe like YouTube started playing, and I was like, no.
No. That's all. That's why Todd went to me.
Yeah. All right. So yeah, we do this every week, Hacky Hours. So join us next Thursday at 10:30 a.m. And we'll see you next week. So thanks, everyone. Thanks, Steve. Thanks, Lila. Thanks again.
All right. Thank you, everybody. Again, just follow up. The Discord's still open. So go there if you got further questions. And, you know, we will work with you in that area. So thank you, everyone.
Thanks. Bye.